three next clips will be a series of small, slightly connected presentations. Nothing new will be presented here, but these clips may clarify some concepts that are already introduced. As such, these clips may later be referred to when I have the need for it. The concept in this particular clip is independence and irrelevant data. In the last clips I've described evidence and I've indicated how various types of evidence changes the model probabilities. Sometimes a concept can be best described by what it's not though. The opposite of evidence is irrelevant data. You've got irrelevant data when the data probabilities does not depend on the models you are contemplating, i.e. the probability of D given M is the probability of D. As such, data can be irrelevant in one setting but relevant in another. For instance, if I throw this die, cover the top side except for one of the corners and show it to you like this, that would be relevant data for the outcome of the die throw but not for the weather outside my house. This can also be expressed as the observation you just saw is independent from the weather outside my window. You've got independent events if the probability for one event given the other does not depend on the other event. Stated a little differently, the probability for event A and B, which always is the probability for A times the probability for B given A, is now simply the probability for A times the probability for B. So the probability for getting a 2 on a die and for it raining outside is the probability for getting a 2 from the evidence here times the probability for it raining outside. The die throw will not function as evidence for the weather, nor will the weather function as evidence for the die throw. This can be illustrated using the Venn diagram approach in clip 4 by letting the model be a vertical stripe in the set of possibilities, and the data can then be illustrated as a horizontal stripe in the set of possibilities. The size of the model possibilities is the same if you condition on the data, zoom in, or if you don't, zoom out. Independence between model and data, irrelevance, may be a somewhat sterile subject, but it needs to be described nonetheless. In addition, the concept of independence can be very useful when dealing with several bits of information. If two data are independent, it's quite a bit easier to deal with the likelihood and thus update the model probabilities. More on that in a later clip. Irrelevance can be a little subtle sometimes though. For instance, you may have heard about the flapping of a butterfly's wings and that it can affect the weather much later. The weather is a chaotic system where small changes in the initial conditions rapidly, in relative terms, leads to large changes in the results. From the example given here, this is often called the butterfly effect. So if you could run the exact same events that affect the weather but change the way the butterfly used its wings, you may get a storm in one setting and calm weather in another, 3 months from now say. Of course you can't run history twice, and even if you had a model that was accurate enough to incorporate such small details, you would need all other such details, also even events happening in the near future, in order to accurately predict the weather far into the future. The reality of weather modeling is far from this ideal, which means that for any realistic weather model, the flapping of the wings of a butterfly is irrelevant to weather modeling, precisely because of the butterfly effect. Since you can't get an accurate specific outcome because of the butterfly effect, you'll instead get a distribution of possible weather. In the same spirit, my die throw will not give you information about the weather outside your house either, even if you are seeing this several months later. And it's usually assumed that one die throw and the next is independent. As long as you do not have information about such a dependency, independent probabilities are called for. You do not want to code for more information than you've got. The point with irrelevant data is that it doesn't change the model probabilities. The posterior probability is equal to the probability prior to the data. Probability of m given d is the probability of m, as long as your model probabilities are not 0 or 1. Only irrelevant data has this property. Again, the opposite of irrelevant data, evidence, is data that does change model probabilities.